Right, hi everyone, Mr. Thomas here, coming from my sick bed. So I'm going to try and finish this paper with some videos. Hopefully you can watch them instead of my lesson, that'd be great. So I think we're up to number 12, so find the values of m for which the equation 4x squared plus 8x minus 8 equals m, brackets 4x minus 3 has real roots. There's the big phrase. That immediately suggests that the discriminant is involved, and that is what this topic is. It's the first time I've used my home pen since lockdown, so I apologize if my handwriting's not fantastic. Probably can't be any worse than it normally is, though. So discriminant, real roots. In other words, b squared minus 4ac is greater than 0. So they give us an equation here, which is not yet in the correct form, but when it is, I can take the a, the b, the c, sub them into this inequality here, and I will have an inequality in terms of the letter m that will be, hopefully, eventually, my answer. And it will make sense as the question goes on. When I said that this question is not correct yet in the correct form, the discriminant will only work when the quadratic is equal to 0, because then, you have a, b, and c in the same positions as you would in the quadratic formula. So, expand the brackets. That's our first step. 4x squared plus 8x minus 8 equals 4mx minus 3m. Okay, we're going to get all of this on the same side. I'm going to try and group certain things together, and group the x's together, and any constants together. I'm going to take everything over to the left and make the right hand side equal 0. So we're going to begin with 4x squared. That's the only x squared term. In terms of the 8x and this, okay, let's just put it together first. We have plus 8x. This is going to become a minus. So we have minus 4mx. And then we had a minus 8, but we also have that plus 3m on the end. So just moved everything over there. Now it's almost in the correct quadratic form, but a bit of factorizing is needed here for my x terms. And this can just be sort of grouped together as the entire constant term on the end. Apologies if you can hear my wife coughing in the background. 4x squared plus, now this second term here, in terms of before x, we're going to have 8 minus 4m, which can be factored out, and the x then, and then we have that entire c term on the end. So we have a, b, c to sub in, so b squared, 8 minus 4m squared, minus 4 times a times c. b squared minus 4ac, according to this, has real roots. That means that it is greater than 0. This now contains only one unknown, that is letter m, and the question's asked me to find the values of m. So therefore, I'm going to get my answer if I expand this and rearrange it accordingly. So we have, so expand my brackets, square the first term, double the product, well, minus 32m, so minus 64m, square the last, plus 16m squared. Take away all of this, so that is minus 4 times 4, which is 16. 16 times 8, calculate the job, is 128, but it's a minus times a minus for the first term, so it's going to be plus 128. And we have minus 16 times 3, so that's minus 48m is greater than 0. Okay, so we're going to have a quadratic here. We have 16m squared. Then we have minus 64, take away another 148, minus 112m. And then we have 128 plus 64 for my constant on the end for 192. Now, I'm looking at that thinking, it's horrendous. I'm not going to factorize that. There's quite a few things I could divide through by. Hopefully 16, but I'm not sure. Yeah, 16 does work. So if I divide through by 16, you end up with m squared minus 7m plus 12 is greater than 0. Now, here you have a quadratic. Now, what's the values of m? Not quite done yet. I'm going to factorize this. So if you factorize it, it's m minus 3, m minus 4, greater than 0. Now, a lot of people would perhaps lose a mark at the end for leaving it as m equals 3 and m equals 4, but it's not equal to 0. It's greater than 0. This is everyone's favorite topic of quadratic inequalities coming into play here. So I'm just going to go up here for a bit more room. We have some critical values of m equals 3 and m equals 4. But what we actually have is excuse me, I don't have a straight line tool here at my disposal. So we have a quadratic graph, this here, where it hits 3 and 4, a very exaggerated graph here, but it doesn't necessarily matter. Well, here we go. There's my quadratic, right, pretend that 4 was there. And I want it where it is greater than 0. And this graph is greater than 0 in this region here, this region here. This one here was when m is less than 3, to the left of the point 3, or m is greater than 4, to the right of the point 4. There's your final answer.